Okay, so we have our impulse and change of momentum homework. Two equations. All right. Mass times the change in velocity is equal to the force times time. All right. Impulse is force times time. These things are equivalent. So if you know what the impulse is, that's how much the momentum is going to change by. All right. Very first one. Super easy. Impulse that acts on this guy. You have a force, you have a time. They just want impulse. So I is equal to F times T. Force was 6 newtons, and the time was 5 seconds. That gives us 30, and the unit for impulse is newtons times seconds. Super easy, right? Cake. What is the change in momentum produced? Well, change in momentum is equal to the impulse. So the change in momentum is just going to be 30, but now you have to give it the right units for momentum. Okay, so now we're going to calculate the change in velocity of this object. So, Jesus, we got the change in velocity. Anytime you see change in velocity, we're looking for delta V. The equation I gave us here is force times time over the mass of the object. So do we have all of them? We do from the part above. 6 newtons times the time of 5 seconds divided by 1.5 kilograms Fine. Okay, what's the unit for velocity though? Hell yeah, meters per second. So if this thing was originally at rest, what would its final velocity be? 20. If it were originally at 10 meters per second, what would its final velocity be? If the velocity changes by 20, let's say it was originally moving at 10 meters per second. So if it's moving originally at 10, let's say VI was 10, and the change is 20, that means the final velocity would have been 30. That's just like a what if kind of a question. All right, that's not on here, but something that may eventually be asked about this. Everybody cool? That's sweet. For how many seconds would a force of 8 newtons have to act on a 2 kilogram mass in order to change its velocity by 5 meters per second? So I gave you the equation there. Time or change in time. It's going to equal mass times change in velocity over the force. And we have those variables in here somewhere. Mass was 2 kilograms. Times a change in velocity of 5 meters per second. Now, I could have, like, the question could have been asked like this. In order to change its velocity from 2 meters per second to 7 meters per second. So in that case, you have to do final minus initial in order to figure out that it would have been 5. But this one, I just gave it as 5. Over the force of 8 newtons. So what is that, 10 divided by 8? I think. Sounds about right. And that comes out to be 1.25, and we're looking for time. So the unit would be in seconds. Not too bad? Okay. If a certain mass has its velocity changed by 1.5 meters per second when a 3 Newton force acts on it for 4 seconds, Find the mass of the object. Okay. So you're given the equation here. The force was how much? 3 newtons. How long did it ask for? Or how long did it act for? 4 seconds. And the change in velocity was 1.5 meters per second. 3 times 4 is 12. 12 divided by 1.5 should be 8. And our unit for mass is the kilogram. Oh. All right. Someone want to tell me what goes where in here? What force is necessary in order to change the velocity of a 2 kilogram object by 7 meters per second in 0.1 seconds? Given the equation here to solve for force, mass goes first. Mass was good, 2 kilograms. What about the change in velocity? How much was that? And the last thing was over the time. So the time was 0.1 seconds. So 14 divided by 0.1 is going to be 140. What's the unit for force? Good, newtons. Okay, so you guys should be able to complete. All right, we did one example for finding the mass, for finding the time, for finding here. So these are the ones we've done. We did basically figure out the change in velocity, figure out the time, figure out the mass, figure out the force. So for 5 and 6, they're just like one of those 4 problems, right? So if we flip it over, number 7 is actually, I like this one because it makes you just have a quick question, quick think. Calculate the momentum of cart 1. So cart 1, momentum is equal to just mass times velocity. So the mass of this cart is not -2. You can't have a negative mass. So it's 2 kilograms times 30 meters per second. What's 2 times 30? Good, 60. The unit, kilogram times meters per second. Cart 2, same idea. P is m times v. The mass of cart 2 is 1.5 kilograms. But this one is moving at a velocity of 40. 1.5 times 40 is 60 kilogram times meters per second. So, are the momentums the same? Yeah. Same magnitude. Just re-look at the quick parts of this. One is going north and one is going south. So it would just be, because it's technically a vector quantity, right? If we want to say like one's negative because it's going to the left, one's positive because it's going to the right, that will matter when we get into collisions. All right, so the first one is, what was the first one? North. Second one was south. So no, because same magnitude. But different directions. Okay. Number 8 is just like one of those first like 4 problems that we did. The equation's given. You have time. You have change in velocity. You have mass. You can calculate that, dude. But let's take a look at number 9. So, like here, we were saying they're not the same because they have different directions. I mean, if this was negative 20 and this was a positive 20, that means something because of the direction that they're going. And something had to have occurred in order to change that direction. So there would have definitely need to be a impulse. So in number 9, the mass of this ball is 0.2 kilograms, and it's thrown against a steel plate, and it rebounds. So here, okay, it's 20 meters per second going into the wall, going out. Now, hopefully you'll be able to figure it out without me having to write this here of which one's the initial velocity and which one's the final velocity. But do note that I did put in, all right, the negative symbol, all right, the negative 20, which comes into play. So to figure out how much the momentum of this object changed, right, what is this? What do we got? Mass, sorry, 0.200 kilograms times VF, which is 18, minus VI, which was a negative 20. So 18, it winds up coming right 18 plus 20, which is 38. And so 38 times 0.2 comes out to be 7.6 kilogram meters per second. Okay. Now we can do either 1 or we can do either do 10 or 11. Which one would you want to do? They're pretty much the same thing. So we're only doing one of them. Well, since today is the 10th, let's do the 10. Wait, but it's also November, which is the 11th. Oh, dang. I did not anticipate this. This is a tricky one. All right, I'm picking 10. Yeah, we're doing 10. 10 is good. Okay, you have a 3 kilogram object that is initially traveling with a velocity of 4 meters per second. what is its initial momentum here? So the initial momentum, it would be the same thing as just what is it originally moving at, its momentum. So mass of 3 kilograms times 4 meters per second is equal to 12 kilogram meters per second. So in number B, or I mean letter B, if a 5 Newton force acts to the right for 0.8 seconds, for 1.8 seconds, what is the new momentum? So a force times a time is an impulse. An impulse means it's going to wind up changing the momentum. So what we have to do first is find the change in momentum and then add it to part A, because this is what it was originally moving at. Then we basically gave it a push. So now it's going to be moving at a new momentum. That's what they want. So to find your change in momentum, delta P, is going to equal force times time. The force was 5 newtons times 1.8 seconds. Cool. That gives us 9 Newton seconds. But remember that an impulse is equal to change in momentum. So 9 Newton seconds is equivalent to 9 kilogram meters per second. So that's the change. That's not the final. The new total momentum would be your 12 plus the 9. Okay, and you're going to get 21 kilogram meters per second. Okay, so you guys will finish you have 1, 2, 3, 4 problems to finish for homework. All right. See you guys.